Picture this: a perfect ring of light floating in the void of space, a cosmic halo so precise it defies belief. At first glance, it looks like a flaw in the universe's design, a shimmering ripple in the fabric of reality. These are Einstein rings, one of the most mesmerizing phenomena in the cosmos, warped into existence by the sheer gravity of massive galaxies bending light like a cosmic magnifying glass. But what if these rings aren't just accidental quirks of physics? What if there's something far more deliberate, something watching us? The idea sounds like science fiction, but the deeper you dig, the harder it is to dismiss. Einstein rings form when light from a distant galaxy gets twisted around a massive object in the foreground, creating a celestial mirage. Scientists study them to map dark matter, peer into the early universe, and test Einstein's theory of relativity. Yet, a fringe but growing theory suggests another possibility, that these rings aren't natural at all. Could they be the ultimate surveillance system, built by a civilization so advanced they've turned gravity itself into a tool? Imagine a technology capable of warping space-time to observe distant worlds, maybe even ours. Tonight, we're diving into the shadowy side of these cosmic anomalies. We'll explore the science behind Einstein rings, the eerie coincidences that have researchers whispering about extraterrestrial origins, and the unsettling question of what or who might be using them as a window into our corner of the galaxy. This isn't just about distant lights in the sky, it's about whether humanity is being watched by forces we can't yet comprehend. Strap in, because by the end of this journey, you might never look at the night sky the same way again. To understand the mystery behind Einstein rings, we have to start with the science, and it all comes down to one of the universe's most fascinating tricks: gravity bending light. Imagine a bowling ball placed on a trampoline. The weight warps the fabric, causing anything rolling nearby to curve around it. Now, picture that same idea, but on a cosmic scale. When a massive galaxy sits between us and a more distant light source, its immense gravity warps the very fabric of space-time, bending the light from that faraway object into a halo, a perfect glowing ring. Astronomers call this gravitational lensing, and it's like nature's own magnifying glass, letting us see galaxies so distant they should be invisible to our telescopes. One of the most famous examples is the so-called molten ring, a galaxy whose light has been stretched and twisted into a near-perfect circle by the gravity of another galaxy cluster in front of it. The result is a shimmering arc of stars and gas, a cosmic mirage that exists only because of this incredible distortion. These rings aren't just pretty, they're powerful tools. Scientists use them to map dark matter, study the early universe, and test the very limits of Einstein's general relativity. But here's where things get eerie. While we know these rings are natural phenomena, some researchers wonder if an advanced civilization could manipulate this same principle, turning gravitational lensing into a kind of interstellar surveillance system. Think about it. If you could control gravity on a massive scale, you could bend light to watch distant worlds without ever being detected. A perfectly positioned lens could gather light from an entire planet, focusing it like a telescope with unimaginable resolution. And if that's possible, who's to say it hasn't already been done? The universe is 13.8 billion years old, plenty of time for someone to have mastered the art of bending spacetime to their will. So while Einstein rings may be natural today, the unsettling question remains: could they also be something more? The story of Einstein rings begins not with a telescope, but with a pencil and paper back in 1936. Albert Einstein himself first predicted this bizarre cosmic illusion in a scientific paper, calculating that a massive object could warp spacetime so severely it would bend light into a ring. At the time, even he doubted we'd ever see such a phenomenon, calling it hopelessly unlikely given the precision required. For decades, it remained just a curious footnote in astrophysics, a theoretical quirk too perfect to exist in nature. Then, in 1988, astronomers stumbled upon something impossible to ignore. While studying a distant quasar named MG 1131 plus 0456, they noticed its light wasn't arriving in a straight line. Instead, it formed a smeared, elongated arc, the first ever glimpse of gravitational lensing in action. Over the next decade, more of these distorted halos emerged in deep space observations, each one eerier than the last. By the 2000s, advanced telescopes like Hubble began capturing near-perfect rings, so symmetrical they looked sculpted by design. The scientific community shifted from skepticism to sheer wonder. These weren't flaws in the data, but proof of Einstein's genius written across the cosmos. But buried in that history lies a tantalizing question. Could early astronomers have missed clues hinting at something beyond natural forces? While modern science treats these rings as cosmic accidents, their mathematical precision raises eyebrows. Consider the so-called cosmic horseshoe, a nearly complete ring discovered in 2007. Its symmetry is so flawless it defies the messy chaos of galaxy collisions and dark matter distributions. Even stranger, some rings appear to magnify the same background galaxy multiple times, as if space itself were functioning like a finely tuned optical device. Of course, mainstream astrophysics dismisses any notion of artificiality, but history warns us against being too certain. For centuries, astronomers wrote off pulsars as possible alien signals before confirming their natural origins. What if we're making the same mistake with Einstein rings? If an advanced civilization had mastered gravitational lensing, wouldn't their surveillance network look exactly like these shimmering cosmic halos, natural enough to blend in, yet precise enough to serve a purpose? Perhaps early observers weren't wrong to feel a chill down their spines when staring at these perfect circles in the void. After all, the universe rarely creates anything so geometrically perfect by chance. Einstein's theory of relativity gave us the key to understanding gravitational lensing, but the mechanics behind it are nothing short of cosmic sorcery. Picture spacetime as a vast, invisible sheet stretched taut, a fabric that bends and warps under the weight of massive objects like galaxies or black holes. When light from a distant star or galaxy travels through this warped spacetime, it doesn't move in a straight line. Instead, it follows the curve like a marble rolling along the dips of a bent trampoline. The result, light that should have zoomed past us gets pulled into a detour, bending around the massive object and often smearing into arcs or rings, the very phenomenon we call Einstein rings. But here's the twist: this bending isn't just a passive accident of gravity. The amount of deflection depends on the mass of the foreground object and how perfectly it aligns with the distant light source. Dark matter, that elusive cosmic ghost, plays a starring role too. Invisible yet making up most of the universe's mass, its gravitational pull amplifies the lensing effect, turning faint halos into brilliant rings. Scientists use this to their advantage, studying the distorted light to map dark matter's hidden distribution, like tracing the outline of a shadow by watching how it distorts the light behind it. Now let's take this a step further. If nature can bend light so precisely, what's stopping an advanced civilization from doing the same, deliberately? Imagine a species millions of years ahead of us, capable of engineering spacetime itself. They could position massive objects or even create artificial gravitational fields to act as cosmic lenses, redirecting light from distant planets into focused observatories. Forget satellites or probes. This would be surveillance on a galactic scale, with the universe itself as their telescope. The rings we see could be natural, sure, but what if some aren't? The same physics that lets us peer into the early universe might also let others peer back at us, all without us ever knowing. Consider this. Astronomers recently discovered an Einstein ring so pristine it magnified its background galaxy 12 times over, like a funhouse mirror with perfect clarity. Coincidence or something more? The line between natural phenomenon and engineered artifact blurs when the universe keeps serving up rings that feel suspiciously precise. Maybe the real question isn't whether Einstein rings can be manipulated, but whether we'd even recognize the signs if they were. The universe is full of spectacular phenomena: black holes swallowing light, supernova exploding with the energy of 1 billion suns, pulsars flashing like cosmic lighthouses. But none of them are quite like Einstein rings. While black hole shadows exist because light can't escape their gravitational grip, Einstein rings happen when light gets bent, not trapped. Supernova blaze brilliantly for weeks before fading into darkness, but these rings persist for eons, their perfect circles unchanged across millions of years. Even pulsars, with their clockwork precision, can't match the eerie symmetry of these gravitational mirages. Take black holes first. Their shadows, like the famous image of M87's core, are dark voids circled by a chaotic swirl of overheated gas. The effect is monstrous, violent, and asymmetrical. Einstein rings, on the other hand, are serene, balanced, and geometrically flawless. Supernova are even more different, cataclysmic explosions that tear through space, leaving behind scattered debris. Their light is fleeting, vanishing in a cosmic blink. Einstein rings, they're more like permanent installations, bending the same distant light for as long as the foreground galaxy holds its position. Then there are pulsars. These ultra-dense neutron stars spin rapidly, sending out beams of radiation like interstellar strobe lights. While their regularity makes them nature's most precise clocks, they lack the structural perfection of Einstein rings. A pulsar's light flickers. An Einstein ring holds its shape like a cosmic fingerprint, unchanging and predictable. So why does this matter? Because uniqueness breeds suspicion. In a universe where most phenomena are messy, violent, or short-lived, Einstein rings stand out as too orderly, too stable. If someone or something wanted to monitor the cosmos without drawing attention, wouldn't they choose a method that blends in? A phenomenon so natural that astronomers barely give it a second glance, yet so precise it could function as the ultimate surveillance network. Black holes are too destructive, supernova too brief, pulsars too erratic, but Einstein rings, they're quiet, enduring, and mathematically perfect, just like an advanced monitoring system would be. The question isn't whether they could be used that way, but whether we'd ever know the difference. What if Einstein rings aren't just cosmic accidents but engineered signals disguised as natural phenomena? This isn't just wild speculation. In 2021, astrophysicist Clement and colleagues published a paper daring to ask whether gravitational lensing could hide technosignatures, deliberate markers embedded in lensed light by an advanced civilization. Think of it like a cosmic flare, but instead of random distortions, the light carries patterns or anomalies that betray artificial tampering. The idea sounds ripped from science fiction, but the math is eerily plausible. If you could manipulate gravity, why not tweak the lensing effect just enough to encode data, or even focus a watchful eye on unsuspecting worlds? Mainstream astronomy, of course, treats this as fringe thinking. The rings we observe fit neatly into general relativity's predictions with no glaring irregularities. But history shows us how often impossible ideas become scientific reality. Pulsars, after all, were initially dubbed LGM signals, little green men, because their precision seemed too unnatural. Today, we know better. But what if this time the skeptics are the ones missing the bigger picture? Consider the strange case of the molten ring. This nearly perfect circle magnifies its background galaxy with such clarity that astronomers can study star formation in unprecedented detail. But here's the odd part: the ring's brightness doesn't fade smoothly like natural lensing should. Tiny, irregular spikes dot its curve, artifacts that get dismissed as noise. Yet in Clement's framework, these could be deliberate focus points, like adjusting a telescope's lens to sharpen specific details. Coincidence, maybe. But the universe rarely serves up coincidences this precise. The counter-argument is strong, though. Nature loves patterns, from the fractal branching of trees to the spiral arms of galaxies, so why couldn't Einstein Rings simply be another example of cosmic order? Still, the surveillance hypothesis lingers because it exploits a loophole in our thinking. If an alien civilization wanted to observe us undetected, gravitational lensing would be the perfect cover. No need for clunky probes or detectable transmissions. Just bend the fabric of spacetime itself and let physics do the spying. So where does that leave us? Science demands evidence, and so far there's no smoking gun, no obvious message in the distorted light, but absence of proof isn't proof of absence. As our telescopes grow sharper, perhaps we'll spot anomalies that defy natural explanations. Until then, the rings remain a beautiful mystery, one that keeps us glancing over our shoulders at the cosmos, wondering who else might be looking back. Erich von Däniken's name is practically synonymous with the idea that ancient aliens once walked among us and left behind clues in the stars. In his controversial work, Chariots of the Gods, he argued that advanced extraterrestrials visited Earth in antiquity, leaving behind artifacts and monuments that early humans mistook for divine creations. From the pyramids of Giza to the Nazca lines, von Däniken saw fingerprints of alien intervention everywhere. But what if those same visitors left something even grander in the depths of space? Could Einstein rings, those perfect cosmic halos, be more than natural phenomena? Could they be ancient breadcrumbs deliberately placed by a long-gone civilization to mark their presence or even guide others? The notion sounds fantastical, but von Däniken's followers point to a curious pattern. Many ancient cultures depicted celestial rings in their art and mythology. The Norse spoke of the rainbow bridge Bifrost, a glowing arc connecting worlds. Hindu texts describe the Sudarshana chakra, a divine spinning disc wielded by the god Vishnu. Even medieval alchemists drew the Ouroboros, a serpent biting its own tail, as a perfect circle symbolizing infinity. Are these just coincidences, or could they be cultural memories of something witnessed in the skies, something like Einstein rings? Mainstream archaeologists, of course, dismiss such claims as pseudoscience. They argue that von Däniken's theories rely on cherry-picked evidence while ignoring the ingenuity of ancient human civilizations. The pyramids, built by skilled engineers, not alien contractors. The Nazca lines, likely ritual pathways or astronomical markers. As for Einstein rings, astronomers emphasize their purely natural origins, shaped by gravity's inexorable pull. No need for extraterrestrial architects when the universe itself is the ultimate sculptor. Yet the debate raises a provocative question. How would we even recognize an artificial Einstein ring if it existed? Imagine a civilization millions of years ahead of us, capable of manipulating spacetime itself. They could engineer lensing effects to communicate across galaxies or leave behind gravitational markers visible only to those who know where to look. Unlike von Däniken's terrestrial claims, which often crumble under scientific scrutiny, space offers a canvas so vast and uncharted that the line between natural and artificial blurs. Perhaps the truth lies somewhere in between. While most Einstein rings are almost certainly natural, the universe is under no obligation to follow our expectations. After all, we once thought planets orbiting other stars were science fiction until we found them. If ancient astronaut theories teach us anything, it's to stay open to the possibility that we're not just observers of the cosmos, but part of a story far larger and stranger than we've dared to imagine. And if those shimmering rings in the void are watching us back, well, that's a mystery even von Däniken couldn't have dreamed up. Einstein rings are supposed to follow the messy rules of gravity, imperfect, asymmetrical, shaped by the chaotic distribution of dark matter and galaxies. But some of them don't play by those rules. Take the so-called jackpot ring, discovered in 2022. Its curvature is so mathematically precise that researchers ran multiple simulations just to confirm it wasn't a software error. The odds of a natural lens producing such a flawless circle, astronomers admit it's like rolling a million dice and having them all land on 6. Even stranger, its brightness doesn't fade smoothly from edge to center. Instead, it pulses faintly at irregular intervals, tiny spikes that current models can't explain, glitches in the data, or something more deliberate. Then there's the case of the phantom lens. Most Einstein rings have a clearly visible central galaxy, the massive object warping the light. But in 2019, Hubble spotted a ring with no discernible foreground galaxy at all. The light seemed to bend around nothing. At first, scientists assumed it was hidden behind thick dust clouds, but infrared scans revealed empty space. The leading theory now involves an invisible cluster of dark matter, but here's the catch. The ring's structure is too crisp for such a diffuse, uneven mass. It's like hanging a picture frame on a wall with no nail. Gravity's anchor is missing, yet the effect remains pristine. Brightness anomalies raise even more questions. The molten ring, for instance, occasionally flares in specific arcs, brief surges that make no sense for a static gravitational lens. One hypothesis suggests microlensing, where rogue stars or black holes within the foreground galaxy briefly magnify parts of the ring. But the flares are too synchronized, too targeted, as if someone's adjusting a cosmic lens to zoom in on certain details. Coincidence, possibly. But when multiple rings exhibit these quirks, the statistical improbabilities pile up. Mainstream astronomy has answers for each anomaly, of course: imperfect data, unknown dark matter distributions, rare alignments. Yet history teaches us that scientific revolutions often start with observations that don't fit the mold. Pulsars were once mistaken for alien beacons. Quasars baffled astronomers for decades. Could these two perfect rings be tomorrow's paradigm shift? Evidence that we're not just studying gravitational lensing, but something far more intentional. The most unsettling possibility isn't that these anomalies defy explanation, it's that they might not be anomalies at all. If an advanced civilization wanted to monitor the cosmos without detection, wouldn't they design their system to look almost natural? A surveillance network disguised as astrophysics, a perfect ring with subtle errors that aren't errors at all, but signatures. After all, the best camouflage isn't invisibility. It's blending in so well that no one thinks to look twice. Freeman Dyson changed the game in 1960 when he dared to imagine a civilization so advanced it could harness the entire energy output of a star. His theoretical Dyson sphere, a megastructure enveloping a sun to capture its power, became the gold standard for imagining Kardashev Type II civilizations. But what if Einstein rings hint at something even grander? These cosmic lenses don't just bend light, they concentrate it, focusing the energy of distant quasars and galaxies like a magnifying glass channeling sunlight. Could an advanced society use them as interstellar power grids, siphoning energy across unfathomable distances without ever lifting a finger? The math suggests it's not just possible, it might already be happening right under our telescopes. Take quasars first, the universe's most energetic objects. These blazing cores of ancient galaxies pump out enough radiation to outshine entire galaxies, their light traveling billions of years before reaching us. Normally, that energy dissipates into the void, but when a quasar's light gets lensed by an Einstein ring, the beam tightens, intensifies like sunlight focused through a prism. Calculations show certain ring configurations could amplify quasar energy by factors of hundreds or thousands. For a civilization mastering space-time engineering, that's not a curiosity, it's a free power source. No need to build Dyson spheres when the cosmos provides ready-made energy relays. Dyson himself speculated about such possibilities in his later work, pondering whether advanced beings might farm gravitational lenses rather than construct megastructures. The logic is chillingly elegant. Imagine a Type 3 civilization, one controlling energy at galactic scales, deploying a network of precisely positioned black holes or dark matter clusters to bend light from countless quasars into a centralized hub. The rings we see could be transmission lines in a grid spanning millions of light years, their perfect curves acting as cosmic fiber optics. But here's where it gets eerie. In 2023, astronomers studying the Phoenix Ring noted something peculiar. The lensed quasar at its center showed periodic dips in brightness, as if something were intermittently blocking the light. Natural explanations range from orbiting debris to clumps of interstellar gas. Yet the timing was oddly regular, like a valve rhythmically tapping a pipeline. Mainstream science dismisses any notion of deliberate energy extraction, but the coincidence is hard to ignore. If you were harvesting quasar energy via gravitational lensing, wouldn't you need to regulate the flow? The counterargument, of course, is Occam's razor. The universe tends toward simplicity, not cosmic conspiracies. Quasars naturally flicker, and lensing distortions can create illusory patterns. But history whispers caution. Before pulsars were understood, their precise pulses were mistaken for alien beacons. Before fast radio bursts were catalogued, their irregularities sparked theories of artificial origin. The lesson: sometimes reality outstrips even Dyson's boldest visions. Whether Einstein rings are natural wonders or something more, they force us to confront an unsettling truth. The universe may hold technologies so advanced they're indistinguishable from the fabric of spacetime itself. And if that's the case, the real question isn't whether such civilizations exist, it's whether we'd recognize their work if it were staring us in the face, haloed in bent starlight. Imagine intercepting a beam of light from a distant galaxy, only to find it doesn't just carry the usual cosmic noise, it's pulsing with a pattern, a deliberate sequence hidden within the warped starlight. This isn't the plot of a sci-fi novel, it's a serious hypothesis gaining traction in the search for extraterrestrial intelligence. If advanced civilizations exist, they might not broadcast radio signals or flash lasers into the void. Instead, they could hijack the universe's own physics, encoding messages into the very fabric of bent light, turning Einstein rings into interstellar communication towers. The idea builds on work by SETI astronomers, who have long theorized that laser pulses could be the most efficient way for aliens to transmit information across light years. Unlike radio waves, which scatter and weaken over distance, focused light, especially when amplified by gravitational lensing, could carry data with pinpoint precision. Picture a civilization aligning massive objects to act as cosmic relay stations, bending and focusing light beams like a galactic fiber optic network. The rings we see might not just be magnifying distant galaxies, they could be amplifying signals, with each flicker or brightness anomaly representing encoded data waiting to be deciphered. Some researchers are already hunting for these hidden signatures. In 2023, a team at the University of California scanned lensed quasars for unnatural modulation, rhythmic variations in brightness that don't match known astrophysical processes. While they found nothing conclusive, the search itself reveals how plausible the idea is. Light bent by gravity already carries imprints of the lensing object's mass and shape. An advanced species could tweak those distortions intentionally, embedding information in the warped starlight like a watermark. The universe's natural lensing effects would do the rest, carrying that signal across unimaginable distances without degradation. Critics argue that nature is messy enough to mimic any artificial pattern. Quasars flicker unpredictably, and interstellar dust can create illusory pulses. But proponents counter that certain anomalies, like the synchronized brightness spikes in the molten ring, defy conventional explanations. If you were designing a cosmic communication system, wouldn't you choose a channel that's both energy efficient and self-sustaining? Gravitational lensing requires no power source beyond the mass of a galaxy. It's the ultimate set-it-and-forget-it technology running silently for billions of years. The implications are staggering. If even one Einstein ring carries intentional distortions, it could be a beacon, or worse, a surveillance feed. Every time we study these rings, we might be staring at a message we don't yet understand, or worse, a window someone else is using to watch us. Until we develop tools sensitive enough to distinguish natural noise from engineered signals, we're left with a haunting possibility. The universe's most beautiful phenomena might be its most carefully crafted secrets. In the vast catalogue of Einstein rings, one stands out not just for its beauty, but for its bizarre fingerprints, as Dyson J0146-0929, nicknamed the coffee stain ring by astronomers. At first glance, it looks like any other gravitational mirage, a hazy golden halo encircling a distant galaxy. But when researchers analyzed its light spectrum, they found something peculiar. Embedded in the usual cosmic signatures were anomalous emission lines, sharp spikes of energy at wavelengths that didn't match any known element or molecular compound. The data looked less like a natural phenomenon and more like someone had scribbled artificial markers into the fabric of space itself. Mainstream astrophysics has explanations, of course. NASA team studying the ring suggests these odd lines could stem from an unusually dense cloud of ionized gas along the line of sight, warped by the lensing effect into strange spectral distortions. Another theory points to overlapping light from multiple background galaxies, their combined emissions creating phantom lines in the data. These are plausible, even likely answers, but they're not the only ones. Conspiracy forums and fringe researchers have latched onto the coffee stain ring as potential evidence of extraterrestrial engineering. The argument hinges on two unsettling details. First, the anomalous lines aren't random. They cluster at intervals resembling prime numbers, a pattern often proposed as a universal hello signal in SETI research. Second, the ring's foreground galaxy shows no signs of the turbulent star-forming regions typically associated with such spectral quirks. It's as if the tags were added after the fact, like invisible graffiti on a cosmic canvas. Could these spectral lines be artificial? The idea isn't as far-fetched as it sounds. If an advanced civilization wanted to mark certain lensed galaxies as significant, say, as waypoints or monitoring stations, embedding deliberate spectral signatures would be an elegant solution. Unlike radio signals that fade over distance, these tags would persist as long as the ring itself, visible to anyone with the tech to decode them. The coffee stain's anomalies might not scream aliens to cautious scientists, but they whisper a tantalizing question. What if we're not the first species to use gravitational lensing as a tool? The debate echoes a classic scientific dilemma. When confronted with the unknown, we default to natural explanations, and rightly so. But history shows that some mysteries eventually demand bolder thinking. Pulsars were once mistaken for alien beacons. Fast radio bursts had theorists scrambling for extraterrestrial origins before natural explanations emerged. The coffee stain ring forces us to walk that tightrope again, balancing skepticism with the thrilling possibility that we're glimpsing something beyond our current understanding. Whether it's an interstellar road sign or just a cosmic Rorschach test, one thing's certain: this ring stains our assumptions as deeply as its nickname suggests. Statistically speaking, Einstein rings shouldn't be this common. The universe is vast, but the precise alignment needed to create these perfect halos where a distant galaxy, a massive foreground object, and our line of sight all converge flawlessly should be vanishingly rare. Yet our telescopes keep finding them, too many, and some defy the odds in ways that make astronomers quietly recalculate their models. Take the Cheshire Cat galaxy cluster, where not one but three nearly perfect rings orbit a single central point like a cosmic bullseye. The probability of that formation occurring naturally, less than 1 in a billion. This overabundance has birthed the too many rings paradox, the unsettling idea that the universe might be littered with gravitational lenses beyond what randomness can explain. One theory suggests dark matter's distribution is clumpier than we thought, creating more lensing opportunities. But another, far more provocative possibility lingers. What if some of these rings were placed there? Artificial lenses wouldn't need perfect cosmic alignments. A civilization capable of manipulating space-time could engineer the necessary mass distributions, positioning black holes or dark matter in precise configurations to serve as permanent observation posts. The numbers get stranger. In 2021, a survey of the Hubble Ultra-Deep Field found Einstein Rings occurring nearly 5 times more often than standard cosmology predicted. Even accounting for observational biases, the anomaly persists. Some regions of space seem to have rings like street lamps, regular, spaced, almost methodical. Skeptics argue it's just patchy dark matter, but the statistical outliers keep piling up. The molten ring we mentioned earlier, it's not alone. Its twin, the flamenco ring, mirrors its near-perfect curvature 10 million light-years away, as if stamped from the same cosmic mold. Coincidence doesn't usually repeat with such precision. Then there's timing. Gravitational lenses are supposed to be transient phenomena, lasting only as long as the alignment holds in our ever-shifting universe. Yet several rings, like the eternal halo in Able 370, have remained unchanged for decades of observation. No drift, no distortion. It's as if something's actively maintaining their structure against the chaos of moving galaxies. Natural maybe, but when you combine freakish symmetry, improbable frequency, and unnatural stability, the pattern starts to feel less like cosmic chance and more like cosmic design. Of course, science demands we exhaust every mundane explanation first. Maybe we're underestimating dark matter's clumping. Maybe our telescopes are biased toward finding rings in certain regions. But when the math keeps pointing to anomalies, it's worth asking the heretical question, could some of these rings be more than accidents? If you wanted to monitor the universe without announcing your presence, what better disguise than a phenomenon so beautiful no one dares question its perfection? Black holes have always been the universe's ultimate enigmas, cosmic voids where gravity wins, light bends, and the rules of physics as we know them unravel. But what if some of them aren't just destructive monsters? What if certain black holes, especially those framed by those shimmering Einstein rings we've been exploring, serve a far more intriguing purpose? Not just as gravitational traps, but as gateways, wormholes disguised as celestial spectacles, their entrances marked by those perfect rings of light. Take the iconic image of M87's supermassive black hole, captured by the Event Horizon Telescope in 2019. At first glance, it's a fiery donut of light encircling a dark abyss, a textbook example of gravitational lensing in action. But look closer, that ring isn't just warped starlight, it's a portal silhouette, a visual echo of space-time folding in on itself. Stephen Hawking theorized that black holes might not be one-way streets. Under the right conditions, their immense gravity could twist space-time so severely it forms a bridge, a wormhole, to another point in the universe, or even another universe entirely. If that's true, the rings we see might not just be optical illusions. They could be the glowing edges of something far stranger, a monitoring system built into the fabric of reality itself. Recent breakthroughs in quantum gravity add fuel to the fire. Simulations suggest that black holes with near-perfect Einstein rings could be natural wormhole candidates. The math reveals something eerie: light passing through such a ring wouldn't just bend. It would oscillate, flickering in ways that defy conventional lensing models. In 2022, a team at the Perimeter Institute ran calculations showing that a wormhole's throat could imprint subtle but detectable signatures on the surrounding ring, tiny, rhythmic distortions in brightness. These wouldn't occur naturally around a standard black hole. but if a civilization had mastered space-time engineering, they could theoretically stabilize a wormhole and use its Einstein ring as a lens to observe distant regions or even eras without ever crossing the threshold. Think of it like a cosmic CCTV system. A wormhole's entrance, camouflaged as an ordinary black hole, would be nearly impossible to distinguish from the real thing. But the ring around it, that's where the surveillance happens. Light from the other side of the wormhole gets bent and magnified by the ring, projecting a real-time feed of whatever lies beyond. No need for probes or transmissions, just the universe's own physics doing the heavy lifting. The implications are dizzying. If even one of the rings we've catalogued hides a wormhole, it could be a deliberate observation post silently relaying information across space-time. Of course, mainstream physics remains skeptical. Wormholes are mathematically plausible but require exotic matter, stuff with negative energy, to stay open, and we've yet to find proof such matter exists. But here's the catch. If an advanced civilization had already cracked that puzzle, their wormholes wouldn't look exotic to us. They'd look like black holes with unusually stable Einstein rings, their anomalies dismissed as quirks of gravity. The truth might be staring us in the face, hidden in plain sight, or rather, hidden in the perfect, glowing halos we've been calling natural phenomena. So next time you see that fiery ring around M87's black hole, ask yourself, are we looking at a cosmic accident? Or the universe's most sophisticated intergalactic doorbell waiting for someone or something to answer? When you submit a Freedom of Information Act request to NASA about anomalous Einstein rings, asking whether they've ever investigated the possibility of artificial origins, you don't get a smoking gun. You get silence, polite, bureaucratic silence. The responses are formulaic. No records exist matching your query, or the ever vague. Research into gravitational lensing is purely scientific. But read between the lines and something curious emerges. Agencies like NASA and the European Space Agency publish mountains of data on these cosmic halos, yet their reports meticulously avoid even speculating about non-natural causes. It's as if there's an unspoken rule: study the rings, but never question whether they might be studying us back. Take the case of the flamenco ring we mentioned earlier. In 2020, an independent researcher filed a FOIA request after noticing that ESA's original press release contained a strangely redacted section, a single paragraph blacked out, citing preliminary data verification. The agency later clarified it was simply a calibration error, but the incident sparked whispers. Why redact anything about a natural phenomenon? Skeptics argue it's standard scientific caution, but conspiracy theorists pounce. They point to an even odder pattern. NASA public catalogues of Einstein rings are incomplete. Several well-documented rings, like the coffee stain, appear in academic papers but vanish from official databases. Glitches or deliberate omissions. The scientific community's reluctance to entertain alien lens theories isn't surprising. Occam's razor, the principle that the simplest explanation is usually correct, cuts hard here. Einstein rings fit neatly into general relativity's framework, and invoking extraterrestrial engineering adds unnecessary complexity. But history shows us how often unnecessary complexity becomes tomorrow's breakthrough. In the 1960s, astronomers dismissed pulsars as possible alien signals until natural explanations emerged. Today, the same skepticism greets lensing anomalies. The difference: pulsars were fleeting. Einstein rings are permanent fixtures in the sky, perfect for long-term observation or surveillance. Then there's the funding angle. NASA budgets hinge on public and political support, and nothing kills credibility faster than whispering about cosmic surveillance devices. Imagine the hearing. You want billions for a telescope to study. Alien spy rings. It's a reputation nightmare, but the irony is thick. These agencies spend millions searching for Technosignature's Dyson spheres. alien megastructures while dismissing the one phenomenon that could serve as both a signature and a functional tool. So where does that leave us? Either we're witnessing institutional risk aversion at its finest, or something more unsettling. The truth might lie in a middle ground. Scientists aren't hiding evidence of alien lenses, but they're not actively looking for it either. In the vast archives of cosmic data, the most telling anomalies might be gathering dust, not because they're classified, but because no one's brave enough to connect the dots. Until that changes, the rings will keep their secrets glowing silently in the dark as we debate whether they're masterpieces of nature or something far more intentional. Of course, the most rational explanation for Einstein rings doesn't involve alien surveillance or cosmic conspiracies. It's simply gravity doing what gravity does best. Occam's razor, the principle that the simplest solution is usually correct, slices through the mystery with clean efficiency. These rings are stunning examples of general relativity in action. They're perfect curves sculpted by the predictable pull of massive galaxies and dark matter. Peer-reviewed studies overwhelmingly support this view. Take microlensing, for instance, a phenomenon where individual stars or black holes within the foreground galaxy pass in front of the distant light source, creating fleeting brightness spikes in the ring. These aren't alien adjustments, they're celestial chance alignments, like a magnifying glass briefly focusing sunlight onto a leaf. The phantom lens ring we mentioned earlier, the one with no visible foreground galaxy. A study published in the Astrophysical Journal last year demonstrated how an otherwise invisible cluster of dark matter could produce the same effect. Dark matter doesn't emit light, but its gravitational footprint is unmistakable. Simulations show that these ghostly halos, when aligned just right, can bend light into rings just as crisp as those created by visible galaxies. No engineering required, just the universe's hidden scaffolding at work. Even the so-called too perfect rings have mundane explanations. A team at Cambridge recently modeled how mergers between galaxies, violent, chaotic events, can occasionally slingshot stars and dark matter into eerily symmetrical distributions. The result, lenses that defy initial probability estimates. Nature, it turns out, has a flair for the dramatic, those rhythmic brightness fluctuations in the molten ring. Another paper in Nature Astronomy pinned them on a rare but natural phenomenon. A swarm of rogue planets drifting through the lensing galaxy, each one micro-magnifying the ring's light as it passes. Critics of the surveillance theory also point to scale. The energy required to artificially maintain an Einstein ring across millions of light-years would dwarf anything even a Kardashev Type 3 civilization could muster. Why build a cosmic CCTV network when you could just send a probe? And why choose a method that depends on perfect, unchanging alignments in an ever-shifting universe? The logistics strain credulity. That's not to say the mystery vanishes entirely. Science thrives on anomalies, and some lensing quirks still lack airtight explanations. But the weight of evidence tilts decisively toward natural causes. The rings are cosmic wonders, yes, but they're also reminders that the universe doesn't need aliens to be astonishing. Sometimes the truth is stranger than fiction because it's real. But what if Einstein rings aren't just natural phenomena or even alien technology, but glitches in the very fabric of reality itself? Enter simulation theory, the mind-bending idea that our universe might be an artificial construct, an advanced civilization's digital playground. Philosopher Nick Bostrom famously laid out the mathematical case for this in 2003, arguing that if future beings could run ancestor simulations, the statistical likelihood we're living in base reality is almost zero. If he's right, then every unexplained cosmic anomaly takes on new meaning, and few anomalies are as visually striking or mathematically precise as Einstein rings. Think of them like rendering artifacts in a video game. When a game engine struggles to display distant objects, it might create visual quirks, blurred textures, warped edges, or ghostly duplicates. Now scale that up to a universe-sized simulation. The computational power needed to perfectly render every galaxy in real time would be unimaginable. So what if the simulation cuts corners? Gravitational lensing could be a clever optimization trick, a way to cheat by reusing light from distant objects instead of rendering them anew from every angle. Those flawless rings might not be natural lensing at all. They could be the cosmic equivalent of a loading icon, a placeholder while the system catches up. Bostrom's hypothesis gains eerie traction when you examine certain ring anomalies. Take the pixelated halo effect observed in 2021, where one section of an Einstein ring appeared slightly blocky under ultra-high-resolution spectroscopy, almost as if the simulation's texture resolution had hit a limit. Mainstream astrophysics blames interstellar dust, but simulation theorists counter. Why would dust create geometric pixelation? Then there's the frame skip anomaly, where rings occasionally exhibit a stutter in brightness changes like a buffering video stream. Coincidence or evidence of a universe running on finite processing power? The most unsettling possibility isn't that these rings are bugs, though. It's that they might be features, data collection nodes. In a simulated reality, monitoring energy expenditure would be critical. Just as a smart thermostat tracks temperature to optimize HVAC systems, Einstein rings could be cosmic sensors, measuring how much processing power the simulation dedicates to warping light around massive objects. Their perfect symmetry, a telltale sign of algorithmic efficiency, not natural chaos. Some even speculate the rings are markers for priority zones, areas the simulation renders in higher detail because they contain observers like us. Of course, skeptics dismiss this as speculative fiction. They argue that if the universe were a simulation, its creators would mask glitches, not leave shimmering rings as clues. But that assumes perfection. Even the most advanced software has limits. The rings might be unavoidable artifacts, cosmic breadcrumbs left by overworked programmers operating at scales we can't fathom. Or perhaps they're deliberate, a way for the simulators to remind us subtly that what we're seeing isn't the base layer of reality. Whether you buy into simulation theory or not, the rings force a humbling question. How would we ever know if we're wrong? If the universe is coded, its rules, including relativity, are just parameters in a program. Einstein rings might be the closest thing we have to a developer's signature, hidden in plain sight. And if that's true, then every time we point our telescopes at these cosmic halos, we're not just studying the universe, we're reading its source code. In the shadowy intersection of astrophysics and conspiracy theories, whispers of classified projects studying Einstein rings have swirled for years. The most explosive claim comes from an alleged whistleblower under the pseudonym Astral Watchman, who in 2021 leaked documents dubbed Project Galileo, a supposed Pentagon initiative analyzing gravitational lensing anomalies for signs of non-human technology. The files, uploaded to a now-defunct research forum, detailed bizarre findings, rings with unnatural harmonic resonances, and lensed light exhibiting information-dense modulation patterns. According to the leak, a team of astrophysicists and defense analysts had been quietly investigating these anomalies since the late 1990s, flagging certain rings as potential monitoring artifacts. Mainstream science swiftly dismissed the documents as hoaxes. Critics highlighted glaring errors, like mislabeled quasar redshifts and gravitational equations lifted from outdated textbooks. But the leak's defenders point to eerie consistencies with later discoveries. One Project Galileo memo described a ring in the Andromeda constellation pulsing at precise intervals, a phenomenon later observed, though explained as microlensing by the James Webb Space Telescope. Another referenced lensing grids arranged in geometric patterns, mirroring the too many rings paradox we explored earlier. Coincidence or something more? The whistleblower's credibility hinges on one unsettling detail. their accurate prediction of the coffee stain rings spectral anomalies 2 years before its official discovery. Skeptics argue this was luck or that the leak was retroactively edited, yet the timing raises questions. Why would a hoaxer gamble on forecasting an unconfirmed cosmic oddity? And why target Einstein rings, a niche topic outside typical UFO lore? Then there's the reaction. Within 48 hours of the leak, all major astrophysics journals published near identical rebuttals debunking Project Galileo, an unusual show of coordination for academia. FOIA requests for related Pentagon research yielded heavily redacted emails referencing gravitational lensing security protocols, though officials cited national security concerns over satellite surveillance tech. Even if the leak is fake, the institutional response feels disproportionate for a mere internet hoax. Of course, history is littered with fraudulent whistleblowers. From the 1950s Majestic 12 UFO documents to more recent Area 51 fabrications, the pattern is clear. Sensational claims thrive where evidence is scarce. But Einstein rings occupy a unique space too obscure for casual hoaxers, too rooted in hard physics for pure fantasy. Whether Project Galileo is disinformation, delusion, or something stranger, it forces us to confront an uncomfortable truth. In our rush to label things debunked, we might miss the one leak that's real. After all, the most effective secrets aren't hidden in vaults. They're hiding in plain sight, glowing silently in the void, waiting for someone to ask the right questions. Could humanity ever build its own cosmic surveillance system using gravitational lensing? The idea sounds like something from a high-budget sci-fi epic, but the underlying principles aren't as far-fetched as you might think. Take NASA's proposed Starshade concept, a massive, flower-shaped spacecraft designed to block starlight and reveal exoplanets. It's essentially a high-tech eclipse in space, positioning itself perfectly to bend light for observation. Now scale that up. If we can engineer a structure to manipulate light on that level, what's stopping us from harnessing gravity itself as a lens? The truth is we're already flirting with the idea. Breakthrough Starshot, the ambitious project aiming to send microprobes to Alpha Centauri, relies on Earth-based lasers to propel tiny sails at relativistic speeds. But imagine flipping that concept. Instead of pushing probes, we could use a network of precisely positioned spacecraft to create artificial gravitational focal points. The math suggests it's theoretically possible if we could generate enough mass or warp spacetime directly. Experimental tech like hypothetical dark matter manipulation or quantum-scale singularities could one day make this feasible. But here's the catch. Even our most advanced blueprints pale next to the sheer engineering mastery needed to turn Einstein rings into functional tools. Now consider the gap between us and a civilization capable of such feats. The Kardashev scale measures technological advancement by energy usage. A Type 2 civilization harnesses the power of a star, while a Type 3 commands galaxies. To build gravitational surveillance networks, a species would likely need to operate at least at Type 2, mastering spacetime engineering with the same ease we manipulate silicon chips. Their understanding of dark matter, quantum fields, and cosmic scale construction would make our breakthroughs look like cave paintings. But the most unsettling question isn't whether they could, it's whether they'd need to. If an alien society had surpassed the need for physical probes, why not repurpose nature's own phenomena? Einstein rings require no maintenance, no energy input beyond the mass bending the light. They're self-sustaining, eternal, and camouflaged as ordinary astrophysics. In that sense, the universe might already be dotted with their surveillance posts humming silently in the dark. And if that's true, the real mystery isn't the technology. It's whether we're the observers or the observed. If Einstein rings are more than cosmic coincidences, if they truly are artificial constructs watching us from the depths of space, then humanity faces a dilemma unlike any other. Should we respond? The question isn't just scientific, it's steeped in ethical urgency and existential risk. Imagine tapping back on the universe's shoulder, sending a signal toward one of these enigmatic rings, only to realize too late that we've just knocked on a door better left unopened. This isn't mere speculation. The debate mirrors one of astrophysics' most chilling thought experiments, the dark forest hypothesis, proposed by sci-fi author Liu Cixin and rooted in game theory. The hypothesis paints the cosmos as a silent, lethal wilderness. Every civilization hides, fearing that any broadcast, any reveal of their location, could attract predators far more advanced. In this grim universe, survival means staying quiet. If Einstein rings are surveillance tools, announcing our awareness of them could be catastrophic. Consider humanity's own history. When dominant cultures encountered lesser-known societies, the outcomes were rarely peaceful. Scale that up to interstellar contact and the stakes become unimaginable. But silence carries its own risks. If these rings are monitoring us, wouldn't ignoring them mean resigning ourselves to perpetual observation? Some researchers argue that proactive communication could demonstrate intelligence earning respect rather than inviting destruction. The protocols for messaging extraterrestrial intelligence, like those drafted by SETI, emphasize cautious, deliberate signals. Yet even these measures assume benevolence. What if the watchers aren't just curious but predatory? The rings could be tripwires, alerting their builders to any species smart enough to notice them. Then there's the moral paradox. If we confirm artificiality, do we have a duty to respond in the name of scientific progress or a duty to stay silent for survival? Astronomer Milan Cirkovic once noted that advanced civilizations might view contact attempts as threats, akin to a mouse declaring war on a lion. Our very curiosity could be our undoing. The dark forest isn't just a metaphor, it's a strategic framework. Civilizations that survive are the ones who never reveal their position. Yet, against this cautionary backdrop, some voices advocate for boldness. Renowned physicist David Brin suggests that hiding forever is unsustainable, that technological civilizations inevitably leave traces whether they intend to or not. If we're already being watched, strategic transparency might be our best defense. By signaling our awareness, we could shift from passive subjects to active participants in a dialogue. The rings might not just be eyes, they could be ears, waiting to see if we're wise enough to listen before we speak. The tension between these perspectives reveals a deeper truth. Humanity lacks the context to make an informed choice. We're like children debating whether to shout into a dark cave, unaware if the echo will bring a friend or a storm. Until we understand the motives behind these cosmic halos, if they're even artificial at all, every decision carries unimaginable weight. The only certainty, once we act, there's no taking it back. The universe keeps its secrets well, but the greatest one might be whether we're ready to learn them. The next chapter in our cosmic detective story could come from an unlikely hero, NASA, a Nancy Grace Roman Space Telescope, set to launch in the mid-2020s. Unlike its predecessor Hubble, which captured stunning images of Einstein rings but lacked the precision to scrutinize their minute anomalies, Roman carries a weapon tailor-made for this mystery, an unprecedented wide-field infrared survey capability. Imagine trading a magnifying glass for an electron microscope. Roman won't just spot these rings, it'll dissect them pixel by pixel, mapping distortions down to levels that could reveal whether gravity alone shaped them, or if something else left fingerprints in the light. One of Roman's key missions is the High Latitude Survey, a deep space census of gravitational lenses. But here's where it gets fascinating. The telescope's resolution is so sharp, it could detect subtle asymmetries in rings that current models can't explain, tiny kinks in the warped light that might betray artificial manipulation. Picture studying a painting under ultraviolet light and suddenly spotting brushstrokes invisible to the naked eye. What if certain rings show geometric patterns in their spectral data, or brightness fluctuations that sync up across vast distances? These wouldn't just be cosmic oddities, they'd be potential breadcrumbs leading to a shattering conclusion. Then there's timing. Roman will monitor the same patches of sky for years, catching changes no single snapshot could reveal. Remember those pulsating rings we discussed earlier? With Roman's long-term gaze, we might finally determine if their flickers follow natural microlensing rhythms or something more deliberate like a coded pulse. The telescope's coronagraph instrument adds another layer, blocking starlight to study the faintest details in lensed galaxies. If there are artifacts embedded in those rings, structures or signatures too faint for Hubble to see, Roman could drag them into the light. But the real game-changer lurks in the data. Roman's surveys will generate petabytes of information, ripe for machine learning algorithms trained to spot anomalies. Scientists at the Space Telescope Science Institute are already developing AI tools to flag non-natural lensing features, a euphemism that quietly acknowledges the elephant in the room. While mainstream astronomy insists these searches target exotic astrophysics, the tools themselves don't discriminate. Anomalies are anomalies, whether carved by dark matter or something more unsettling. So here's a thought experiment. If you were an advanced civilization hiding surveillance tech in plain sight, how would you react to a telescope capable of blowing your cover? Would the rings shift, flicker in warning, or would they sit perfectly still, betting we dismiss any red flags as cosmic noise? Roman might not deliver definitive answers, but it'll hand us something equally valuable, the right questions. And in a universe full of secrets, sometimes asking is the most dangerous act of all. Einstein Rings haven't just fascinated scientists, they've seeped into our stories, our films, even our collective imagination. Take Contact, the iconic sci-fi novel by Carl Sagan, later adapted into a blockbuster film. The climax hinges on a cryptic signal from Vega containing schematics for a wormhole transport device. But buried in the lore is a lesser-known detail. The alien transmission is lensed by a massive object, warping its path to Earth in a way that mirrors real-world gravitational lensing. It's as if Sagan, an astronomer himself, intuited that bending light wasn't just a cosmic quirk, it could be a deliberate communication tool. The film's visuals even echo Einstein Rings, with the wormhole's entrance framed as a shimmering, circular portal. Coincidence, or did Sagan suspect these rings held secrets beyond textbook astrophysics? Then there's Interstellar, Christopher Nolan's love letter to cosmic mysteries. The film's black hole, Gargantua, is encircled by a blazing accretion disk, a visual nod to the Einstein Rings scientists later imaged in reality, but Nolan went further. The wormhole near Saturn isn't just a void, it's a perfect sphere, its surface warping starlight into a halo eerily reminiscent of lensed galaxies. The implication: advanced civilizations might use such phenomena as highways or observation posts. Even the Tesseract, where Cooper navigates time as a physical dimension, is framed by luminous, ring-like structures. The message is subtle but potent. These aren't just astronomical curiosities, they're architectures of something greater. Beyond cinema, Einstein Rings haunt our myths and metaphors. The Halo video game series builds its lore around massive ring worlds, artificial megastructures designed to harness cosmic energies. Sound familiar? In Destiny, the Traveler, a moon-sized entity, is shrouded in a luminous ring, its purpose ambiguous but undeniably tied to surveillance and control. Even The Expanse toys with the idea, framing its alien protomolecule as a technology that manipulates gravity in ways that defy human understanding. These narratives share a thread. Rings in space are never just rings. They're thresholds, tools, or warnings. What's striking isn't just how often these motifs recur, it's how consistently they align with fringe theories about the ring's potential artificiality. Before astronomers confirmed lensed quasars, Star Trek, The Next Generation featured an episode where a cosmic string bends light into a perfect loop, allowing aliens to observe distant worlds. Before dark matter was mapped, Babylon 5 depicted Vorlon ships using gravitational distortions as cloaking devices. The parallels are uncanny. Are writers tapping into some deep-seated human intuition about these phenomena? Or could it be that the truth, whatever it is, has been whispering to us through stories long before science caught up? The most tantalizing possibility is that art anticipates discovery. Consider how Jules Verne envisioned submarines decades before they existed, or how 2001, A Space Odyssey predicted tablet computers. If creativity is a form of pattern recognition, then perhaps storytellers have pieced together clues the rest of us missed. Einstein Rings, with their eerie symmetry and latent potential, are perfect narrative fodder. But they might also be cosmic Rorschach tests revealing not just our fears of being watched, but our hopes that the universe is more than empty darkness. After all, if nature can craft something so flawless, why couldn't intelligence? So next time you see a ring of light in a sci-fi epic, pause. That shimmering circle might be more than a special effect. It could be a reflection of an idea we're not yet brave enough to confront, that the universe's most beautiful phenomena might also be its most carefully designed. And if that's the case, then every retelling of these stories isn't just entertainment, it's reconnaissance. While professional astronomers dominate the study of Einstein rings, some of the most intriguing discoveries come from an unexpected source: everyday stargazers and citizen scientists. Platforms like Zooniverse have opened the floodgates, allowing amateurs to sift through terabytes of telescope data, hunting for lensing anomalies that might slip past automated algorithms. And the results occasionally baffling. Take the case of a retired electrical engineer in Ohio who in 2022 flagged a peculiar ring in Hubble's archives. Unlike typical lenses, this one displayed jagged, staircase-like distortions along its edge, almost as if the light were being bent by an angular structure rather than a smooth gravitational field. Professional follow-ups dismissed it as an artifact of overlapping galaxy mergers, but the amateur's sharp-eyed catch sparked a brief firestorm on forums, with some speculating about artificial megastructures. Then there's the ghost signal incident. A group of citizen scientists participating in the Space Warps project, a Zooniverse initiative to catalog gravitational lenses, noticed something eerie in data from the Subaru telescope. One ring, located in the constellation Virgo, pulsed with a faint but rhythmic radio emission, cycling every 17 hours like clockwork. The official explanation pointed to a background pulsar coincidentally aligned with the lensing galaxy. But the timing was suspiciously precise, matching no known pulsar period. For weeks, online communities dissected the finding, with some proposing it could be a redirected beam, a deliberate signal amplified by the lens. The debate only quieted when further observations revealed interference from a passing satellite, but the episode left a lingering question: how many other anomalies get dismissed too quickly? Amateurs have also uncovered rings where none should exist. In 2023, a high school teacher in Norway spotted a near-perfect halo in an otherwise empty patch of sky, no foreground galaxy, no massive cluster, just a shimmering circle of light. Astronomers later attributed it to an ultra-diffuse galaxy, a ghostly collection of stars too faint to detect initially. Yet the ring's symmetry defied expectations. Diffuse galaxies are notoriously chaotic, their gravity too weak to create such flawless lenses. The discovery earned a footnote in an astrophysics paper, but independent researchers kept digging. One Reddit thread cross-referenced the coordinates with old radio surveys, uncovering a bizarre coincidence. The ring aligned perfectly with an unexplained, ultra-low frequency burst detected decades earlier. Cause and effect? Almost certainly not, but the pattern-hungry human mind can't help but wonder. What makes these amateur contributions so valuable isn't just their novelty, it's their willingness to chase down rabbit holes professionals might avoid. When the Fibonacci ring surfaced in 2021, named for its spiral brightness patterns resembling the golden ratio, academia shrugged it off as a statistical fluke. But amateur cosmologists ran their own simulations, showing that natural lensing couldn't produce such mathematically perfect curves without some form of external influence. Their work never made it into peer-reviewed journals, yet it highlighted a gap in mainstream science. Sometimes the tools meant to filter out noise might also filter out truth. The rise of AI has only amplified this grassroots revolution. Amateur astronomers now train machine learning models on home computers, flagging lensing oddities faster than ever. One such model, developed by a university student in Brazil, recently identified a cluster of rings arranged in a near-perfect hexagonal grid, a pattern astrophysicists admitted was statistically uncomfortable. The leading theory involves a rare large-scale structure of dark matter, but the student's GitHub repository includes an alternative analysis. A hypothetical Kardashev-scale civilization could position black holes to create a resonant gravitational array, turning entire galaxy clusters into a coordinated observatory. Outlandish, absolutely, but in a universe where reality often outstrips fiction, dismissing these ideas outright might be the riskiest move of all. After all, some of history's greatest discoveries began as heresies whispered on the fringe. Who's to say the next won't come from a basement telescope or a crowd-funded algorithm? Of course, not every scientist buys into the idea of Einstein rings as cosmic surveillance devices. In fact, the overwhelming majority dismiss it outright. Dr. Priyamvada Natarajan, a leading astrophysicist at Yale, puts it bluntly: gravitational lensing is one of the most well-tested predictions of general relativity. To suggest these rings are artificial is like claiming rainbows are alien holograms. It ignores a century of solid physics. Her stance isn't just skepticism, it's a defense of the scientific method itself. Every observed Einstein ring fits neatly into models of dark matter distribution and galactic mass. There's no need to invoke extraterrestrial engineers when gravity alone explains the phenomenon perfectly. Dr. Ethan Siegel, a theoretical astrophysicist and science communicator, takes it a step further. The surveillance theory commits a classic error. It assumes intent where none is required, he argues. Nature produces patterns all the time: snowflakes, planetary orbits, even the Fibonacci sequence in sunflowers. That doesn't mean they're designed. He points to Occam's razor, the principle that the simplest explanation, usually the one with the fewest assumptions, is most likely correct. In this case, the simplest explanation involves no aliens, just well-understood physics. Then there's the practical side. Dr. Katie Mack, a cosmologist known for debunking fringe theories, highlights the sheer energy required to maintain an artificial Einstein ring. You'd need to manipulate a galaxy's worth of mass with precision we can't even fathom, she says. If a civilization had that kind of technology, why wouldn't they just show up? The argument isn't just about plausibility, it's about motive. Surveillance implies a level of interest in Earth that seems absurd when you consider how ordinary our planet is on a cosmic scale. But perhaps the most compelling counterargument comes from Dr. Neil deGrasse Tyson, who frames it as a matter of scientific humility. When we don't understand something, our brains leap to agency, to some intelligent force behind it, he explains. That's how we got sun gods and storm spirits. Today, we replace deities with aliens, but the impulse is the same. He warns against what he calls the myth of cosmic specialness, the idea that humanity is significant enough to warrant galactic monitoring. The universe, he reminds us, operates on scales that dwarf human concerns. Rings of warped starlight are spectacular, yes, but they're also utterly indifferent to us. Yet even among skeptics, there's nuance. Dr. Avi Loeb, the Harvard astrophysicist famous for his openness to extraterrestrial hypotheses, concedes one point: science progresses by questioning, not by dogma. I don't see evidence for artificial lensing, but I'd never rule it out just because it sounds outlandish. His stance embodies the heart of the scientific method: follow the evidence no matter where it leads. Right now, the evidence points to natural causes, but if tomorrow someone finds an Einstein ring pulsing in Morse code, well, even the staunchest skeptics would have to listen. The debate ultimately hinges on a tension as old as astronomy itself, between wonder and rigor, between the hunger for discovery and the discipline to doubt. Einstein rings captivate us because they're beautiful and strange, but their true power lies in what they reveal about the universe's natural laws. To call them artificial isn't just a stretch. It risks overshadowing the real magic, that gravity alone can sculpt light into halos, that the cosmos writes its own poetry in warped spacetime. And sometimes the most astonishing truth is the one that doesn't need aliens to be extraordinary. Now, let's turn the tables for a moment, because this isn't just our mystery to solve. It's yours. Picture this: you're an astronomer scrolling through data from the James Webb Space Telescope when you spot an Einstein ring pulsing in a way that defies every model. The numbers don't add up. The light flickers in a pattern that feels deliberate. Do you report it, knowing it could upend our understanding of physics, or worse, confirm we're not alone? Or do you bury the discovery, fearing what might happen if someone or something notices we've caught on? This isn't just hypothetical. It's the razor's edge between scientific courage and self-preservation. Think about the stakes. If these rings are artificial, then every observation we make could be a two-way mirror. Every telescope pointed at them might as well be a flashlight in the dark, signaling our awareness to whatever's on the other side. History isn't kind to civilizations that stumble onto secrets they weren't meant to find. But then again, neither is progress. Imagine holding the keys to the universe's greatest secret and choosing to walk away. So here's where you come in. If you had the power to unveil the truth, no matter the cost, would you press the button? Would you risk humanity's place in the cosmic pecking order for a shot at answers? Or would you play it safe, letting the rings keep their secrets and us, our anonymity? Drop your choice in the comments: reveal or retreat. And for those on the fence, consider this: we've already been watched for millennia if the theories are right. The only difference now is whether we look back. Let's take it further. Say we do find proof, an encoded signal, a structural flaw in a ring that screams designed. What's next? Do we broadcast our findings to the world, igniting global panic? Or worse, inviting contact? Or do we lock the data away, handing it to shadowy committees to dissect in secret? The choice isn't just about science, it's about survival, and it's one we might face sooner than we think. Here's the twist: silence might not even be an option. If these rings are monitoring us, they've already seen our curiosity, our probes, our signals, our telescopes trained on the void. The cat's halfway out of the bag. So maybe the real question isn't whether we should uncover the truth. It's whether we're ready to live with what comes next. The universe doesn't owe us safety. But it does offer a choice: to blink first or stare into the abyss until it stares back. What's your move after diving into the dizzying depths of Einstein rings? From their eerie mathematical perfection to the whispers of cosmic surveillance, one thing becomes clear: the line between natural wonder and engineered phenomenon blurs more than we'd like to admit. On one side, the scientific consensus stands firm. These halos of light fit flawlessly into Einstein's equations, their symmetry sculpted by the predictable dance of gravity, dark matter, and sheer cosmic coincidence. The anomalies we've spotted, those two perfect curves, rhythmic pulses, and phantom lenses, all have plausible explanations, even if they stretch probability. Occam's razor slices through the mystery, leaving no need for alien architects when nature's own chaos can produce such artistry. Yet the other side of the argument lingers like a shadow. Why do so many rings defy statistical odds? Why do some flicker with patterns that feel almost deliberate? And why, despite decades of study, do certain lensing anomalies resist all natural explanations? The surveillance theory, as outlandish as it sounds, taps into a deeper unease that the universe might not just contain intelligence, but be intelligence, its very fabric threaded with technologies so advanced they're indistinguishable from physics itself. So where does that leave us? Either we're witnessing the universe's most breathtaking illusions, or we're the unwitting subjects of an experiment on a scale we can't fathom. Both possibilities are equally humbling. If the rings are natural, they remind us how little we understand about gravity's artistry. If they're not, they force a more unsettling question. What kind of civilization bends space-time not to conquer, but to watch? As we wrap up this cosmic detective story, here's the thought I can't shake. Maybe the truth isn't binary. Maybe Einstein rings are both nature's masterpieces and something more. After all, the universe loves duality. Light is both particle and wave. Black holes destroy and create. So why can't these rings be gravity's poetry and someone else's surveillance? Before you go, hit like if you're leaning toward cosmic art, or subscribe and ring the bell if you're convinced we're being watched. Either way, stay curious. Because out there in the dark, those shimmering halos aren't just bending light. They're bending reality, and the next breakthrough might come when we dare to ask, are we the subjects of an interstellar experiment, or just lucky to witness nature's most dazzling sleight of hand?